Okay, today's lesson is interpreting complicated expressions, which basically is where they give you problems and situations in English and you're going to translate them to math. So you're going to be using a variety of things that you've already looked at the second slide here. And you're going to show that x plus 2 times 2x minus 1 as a quadratic expression by writing it in the form of ax squared plus bx plus c, and then you're going to identify a, b, and c. So the first thing you're going to do is multiply and use the FOIL method. So pause the video and multiply it out and see what you get, and then come back and we'll check it together. Okay? So if you multiply the first two, x times 2x is 2x squared. The outer two, x times negative 1, negative 1x. The inner two, 2 times 2x is 4x. And the last two, 2 times negative 1 is negative 2. We shall combine like terms and end up with 2x squared plus 3x minus 2. Can't combine any more than that because x squareds and x's don't combine. They certainly don't combine with constants. So now we just look. The letter or the number in front of the x squared is always a. So a is 2. B is the number in front of the x, which was 3. And the c is the constant, which is negative 2. Remember that the sign goes with the number. So, how does that look? All right, now this is a thinking problem, which sometimes are difficult, but we'll walk through this. X plus 7, x minus 10. What values make this negative? So, when we multiply one side times the other side, in order to get a negative number, one of them has to be negative. So if the first one's positive, when you multiply them together, then the answer to the next one has to be negative for you to come out with a negative answer. Or the first one can be negative, the second one can be positive, and we still come out with a negative answer. If both are positive, we end up with a positive answer, which is not what we want. If both are negative, we come out with a positive answer, and that's not what we want either. So we'll get rid of those and realize that this is what we're going to work with. So in the first situation here, in order to get a positive out of the x plus 7, what kind of numbers would x have to be when you add it to 7 would make it positive? Well, I'm thinking in my head, negative 7 plus 7 would give me 0. So anything larger than negative 7 would work to give me a positive there. And then in the x minus 10 part, if I want to find 0, positive 10 minus 10 gives me 0, but I want something less than that to make a negative. So x would have to be less than 10. So for our first scenario, we have negative 7 and 10 on a number line, and greater than negative 7 would start it this way, and then we'd stop when we got to 10. So any of these numbers in here would work for that scenario. Okay, so our second scenario is kind of just the opposite, where now we want a negative. So we look at negative 7 plus 7 to give us 0, but if we want something less than 0, which a negative is, then we want something less than negative 7. On the 10 minus 10, that would give us 0, and so we want stuff larger than 10 to give us a positive number. And the scenario for that one would be, with the negative 7 and the 10, stuff greater than 10, which would give you a very messy arrow going that way. And then less than -7. So you have two possibilities, the one in the red and the one in the green. Okay, another thinking problem. How does the area of a square change when the side length is halved? Okay, so pause for a little bit and see if you can think of what to do there. So here's a square, well, close to a square. And if you remember, the area of a square is length times width, but if they're all sides, then they're all the same, so it would be side squared, or length times width, either one. So let's say we have this example, and each of them is 4. Okay, so the area of that one is side squared, which is 4 squared, or length times width is 4 times 4, and the area is 16. Now the problem says what happens when the side length is halved. So now I would take a new square and make each of the sides half. So my new area would be side squared, or 2 times 2, which is 4. And then you're going to compare the 4 with the 16. So what do you think you discovered? When the area of the side length is halved, what happens to the area? It's down by 1/4, you're right, or it's square rooted. All right, well, this is it for this one. So if you have questions, ask your teacher. If you don't, then go ahead and get started on your assignment.